Okay, we'll finish up section 3.4 in this section. So right now we're on the remainder theorem. And the remainder theorem says that if a polynomial f of x is divided by x minus k, then the remainder is f of k. Okay, so in this example that I was using earlier on this this page, so we worked through the long division process for dividing these polynomials, and then I showed you how to do the same problem again by using synthetic division. You get the same answer there. Okay, so what if I take f of x to be the numerator of this guy? So f of x is 2x cubed plus 7x squared minus 5. And if I divide by x minus k, so k is negative 3, right? Because x minus negative 3 is the same as x plus 3. The remainder is f of negative 3. Okay, so the remainder here is 4. We already did that, right? So if I plug in negative 3 into the function, I should get 4. Okay, so let's check that. So negative 3 cubed is negative 27, times 2 is negative 54, plus 7 times negative 3 squared is 9, 7 times 9 is 63. Negative 54 plus 63 is 9. And 9 minus 5 is 4. Okay, so 4 would be the remainder if we had divided 2x cubed plus 7x squared minus 5 by x plus 3. We did that, right? And here's 4 is the remainder. Okay. Now, through some playing around, if I just check f of negative 1, here's f of x. F of negative 1 is what? Well, negative 1 cubed is negative 1, times 2 is negative 2, plus negative 1 squared is 1, times 7 is 7. So I got negative 2 plus 7, that's 5, minus 5 is 0. Okay, so because I'm getting 0 left over, what that means is that x minus a negative 1, or the same as x plus 1, that would be a factor of f. Okay, so if I were going to try to factor f, now f is a degree 3 polynomial, and you're going to do lots of things with degree 3 and degree 4 polynomials coming up here, okay, and specifically factoring them. So the remainder theorem is going to be very important here. Well, I already know one of the factors. It's x plus 1, okay. And I would also say then that x plus 3, x minus a negative 3, that's not a factor because I'm not getting 0. Okay? All right, let's try these last two examples here. So in this next problem, I want us to factor f of x equals 2x cubed minus 3x squared minus 5x plus 6 if k equals 1 is a 0 of f. Okay, so they're telling me one of the answers. K equals 1. Okay, I need to find the other answers. Now, some books don't even do that. Some books will just say, here's a polynomial, find all the zeros. Okay, and you'll see a little bit of that coming up also in the next section. So knowing that 1 is a 0 means that f of 1 is 0, right? More importantly, though, knowing 1 is a 0 means that x minus 1 is a factor. Okay, so if we divide 2x cubed minus 3x squared minus 5x plus 6 by x minus 1, I can continue to factor this further. By the way, I'm trying to factor f of x. Now, f of x is a degree 3 polynomial, okay? There's an even number of terms. Now, factor by grouping is not going to work, no matter what I decide for the groups. That's not going to work. I don't have a common factor, so this procedure here is the only way to do this problem. Okay. Well, I'm dividing by a binomial, x minus 1. So let me go ahead and use the synthetic division process. You can only use synthetic division if you're dividing by a binomial. 1 is the 0 of the denominator, because 1 minus 1 is 0. Okay. So then the top row would be just where I'm picking off the coefficients in front of each of these terms here. So I got a 2 in front of x cubed, a negative 3 in front of x squared, a negative 5 in front of x, and a 6 at the end. Okay, now I'm all set up to begin synthetically dividing. So I'm going to bring the 2 down. 2 times 1 is 2. Negative 3 plus 2 is negative 1. Negative 1 times 1 is negative 1. And then negative 5 plus negative 1, that's negative 6. Negative 6 times 1 is negative 6. 6 plus negative 6 is 0 left over. Now that should make total sense that we got 0 left over because we already said that 1 is a 0. Okay, there would be a big problem if I were getting any other number left over in dividing. Okay, now I'm more concerned about this 2, negative 1, and negative 6 here. Okay, that's going to be important for us. So so when we take 2x cubed minus 3x squared minus 5x plus 6 divided by x minus 1, we get 2x squared minus x minus 6. Okay. By the way, so in these problems here, you'll always have 0 left over. Okay, again, if I give any other number for the remainder left, I didn't divide correctly then. Okay. Well, let me go ahead and take this equation and we'll multiply both sides of it by x minus 1. So I'm going to have 2x cubed minus 3x squared minus 5x plus 6. That's all alone. And now that's what I'm calling f of x. Right? We're supposed to factor f of x. Okay, that's equal to x minus 1 times 2x squared minus x minus 6. So you can see that I've already started to factor f of x. I just got to continue factoring it. Okay, let's factor 2x squared minus x minus 6. Well, that's going to factor nicely. You got 2x and x. And then for the factors of 6, I'm going to use 3 and negative 2. That's a negative 6. Okay, so let me check this. So 2x times x is 2x squared. Negative 4x plus 3x is negative x in the middle. And then 3 times negative 2 is negative 6 at the end. That was good. Okay, so this would be the function in a complete factored form. Now, if I wanted to find the zeros, all I would do is set each factor equal to 0. So x minus 1 equals 0 means that x is 1. 2x plus 3 equals 0 means that x is negative 3 halves. And then x minus 2 equals 0 means that x is 2. So these three numbers would be the three answers then, if I were to solve this equation here. Okay, let me show you another kind of similar problem here. And in this next one, let's find the zeros for the function f of x equal x cubed plus 6x squared minus 5 if k equals negative 1 is a 0 of f. All right, so I know one of the answers. And by the way, there's going to be 3 answers because I've got a degree 3 polynomial. And check it over here. I had a degree 3 polynomial. I have 3 answers. There's a connection going on. I'll mention that after this problem here. Okay, so I know there's going to be 3 answers. Now they're telling me one of the answers, negative 1. Some books don't do that. Okay, I have to find the other 2 answers. Knowing that negative 1 is a 0 means that f of negative 1 equals 0. More importantly, though, knowing that negative 1 is a 0 means that x minus a negative 1, or x plus 1, would be a factor. So let me divide x cubed plus 6x squared minus 5 by x plus 1. And we'll factor this kind of further, just like we did with this problem. Now, by the way, I've got a degree 3 polynomial. Okay, factor by grouping is not going to work. I don't have anything in common to these three terms here, right? So this procedure that I'm doing, this is the only way to do this problem. Okay. Well, let's see. -1 is the 0 of the denominator, because -1 creates 0 in the denominator. And then the top row, let's see, I got a 1 in front of x cubed, a 6 in front of x squared, a 0 in front of x, and then a -5 at the end. Again, don't ever skip terms. Okay, so if I'll see this on students' papers. Well, they'll say 1, 6, -5. Hey, you get a wrong answer then. Okay, so don't ever skip terms. If you don't have a term there, you're going to write 0. Okay. Now, before I divide, the remainder I know is going to be 0, because I already know that -1 is a 0 of f. Okay, so let me go ahead and divide, and we'll check that. So bring the 1 down. 1 times -1 is -1. 6 plus -1 is 5. 5 times -1 is -5. 0 plus -5 is -5. And -5 times -1 is 5. -5 plus 5 is 0 left over. That was good. That's what we expected. Okay? So we are more interested in what is to the left of 0. So if I divide these two expressions, take x cubed plus 6x squared minus 5 over x plus 1, I get x squared plus 5x minus 5. Okay? And let's see. So I want to find the zeros of f. Well, let's go ahead and multiply both sides of this equation by x plus 1. So x cubed plus 6x squared minus 5, that would be equal to x plus 1 times x squared plus 5x minus 5. That's what we're calling f of x. Okay, and we're trying to factor f of x. Well, you can see that we've already started to do that. Okay, x plus 1 equals 0. That means that x is -1. And that was the 0 that was given to me, right? So I didn't find any answer here. It's -1 is an answer, right? Now I said that there's going to be 3 answers though. The other 2 answers are going to be found by solving this quadratic. Okay, so if I said x squared plus 5x minus 5 equal to 0 and solve that, let's see, factoring is not going to work, right? Because the factors of 5 are only 1 and 5, no matter how I swing that. I'm not going to get 5 in the middle. So let's use the quadratic formula here. X is equal to the opposite of b, so that's -5, plus or minus the square root of b squared. 5 squared is 25. Minus 4 times a is 1, times c is -5. And this is all over 2a. 2 times 1 is 2 in the denominator. Okay, 25 plus 20 would be 45. And root 45, that breaks down as 3 root 5. Okay, so here's my other 2 answers. -5 plus or minus 3 root 5 all over 2. Okay, so all in all, I have 3 zeros. They are -1, -5 plus 3 root 5 all over 2. That's another 0. And then the third 0 would be -5 minus 3 root 5 all over 2. Those 3 answers are the solutions. Okay. Now, from this, we have the fundamental theorem of algebra. I've kind of mentioned this, along the way, just to have you kind of see where it's coming from. But it says that every polynomial function of degree n has at least 1 0 and has at most n zeros. Okay, so in other words, if I give you this function, x cubed plus 6x squared minus 5, I can know right away that there's going to be 3 answers if I set that equal to 0. Because I've got a degree 3 polynomial. okay? And in this problem, I can know right away I'm going to have 3 answers, right? Because I've got a degree 3 polynomial. So the degree will tell you how many answers you'll have, okay? And that's very important, okay? All right, we'll go ahead and stop the video right here. Here's the homework in section 3.4, and I'll start in on 3.5 then in the next video.